Okay, hi guys. So not a lot of people came today, but that's actually good because I want to use today to talk a bit more about just the homework. We're just going to do a run through of it. If we have time, we're also going to do the extra practice. But you guys may have remembered me from the PA session or from the midterm practice exam. I'm going to do things a bit faster today. Okay, but I hope you guys will still be able to understand it. Okay, so let's begin with question one. The thing is, I could technically try to alternate between, okay, the questions and this, but it's going to take a bit of time. So instead, you guys could just, open your browser, have the homework up, and you'll see. So let's begin. Question one, government introduces a price ceiling, okay? Government introduced a price ceiling. Now, here is the counterintuitive part about price ceilings and floors, is that you might think, right, ceiling means top, floor means bottom, so, ceiling should be above the equilibrium and floor should be below it. But that's not it, okay? If you put a ceiling here, it's not going to work. So why is that? Now let's go back to the definition of ceiling. Ceiling just means max, okay? The maximum price you're going to charge. If you're going to put the maximum price here, whereas the equilibrium is here, but nobody was going to give a damn about the maximum price. They're still going to go for equilibrium. And with that, they're also going to go for the equilibrium quantity. So there's really no reason to have a price ceiling above your current equilibrium price. So a price ceiling, in order for it to work, it actually has to be below the equilibrium, right? If you set a max price below the equilibrium, then okay, yes, people will go for it, right? So the same thing with price floor. If you have to set it above the equilibrium in order for it to work, otherwise it's meaningless. So now, not the best graph, I guess, but let's do it, okay? So we impose a price floor, and let's say we impose it here. Okay, so now we have a price floor. As you can see, this is demand, this is supply. We have more quantity demanded than quantity supplied. That means we have a shortage of goods, okay? P. And this is our price ceiling. But what else do we see? You're trying to find surplus, right? So now let's just take a look. So what surplus definitely goes down? It would be the producer surplus, right? Because you can see it went from a bigger triangle to a smaller triangle, something within it. So it definitely went down, okay? PS definitely went down. Well, what about consumer surplus? Okay, so at first glance, it might appear that consumer surplus actually increased because consumer surplus increased by this much, but it lost this little, right? So you might say, oh, consumer surplus increased. But no, okay, it's actually may increase or decrease. And here would be the graph that would illustrate it for you. Let's say if we have a very, very low price ceiling, okay, basically, normally we charge this good, let's say 20, and today you set the max price like 2. It's ridiculous, but maybe some people do it, some governments, okay? So we have a very low price ceiling. Obviously, our price producer surplus decreases. But what about our consumer surplus? So let's see, your consumer surplus went down by this much, it went up by this much. Looking at this, honestly, you might say that I gained a bit more, but you don't really know. And the fact of the matter is, if you go for even more extreme value, you might realize that this part will actually decrease. So this part, the amount you gain, is actually less than the amount you lost. So the point when you answer a question about price ceiling or price floor, okay, is that one will definitely decrease and the other one may increase or decrease. So that's the point, okay? PS goes down, but CS may down or up, okay? Now, price floor would just be the reverse logic. And it's sort of the same. I'm just going to run through it quickly. Again, if it's a functional price floor, it has to be above the equilibrium, right? Because it's minimum price. If you set a minimum price below the equilibrium, well, I mean, people are just going to go for the equilibrium. And nobody cares about the minimum. But if your minimum is above the equilibrium, then okay, people would actually choose, oh, I think, going for the minimum price is the best possible thing when we can't go for the equilibrium or anything under this minimum, right? So with this, we have a surplus price floor. We have it, and you'll realize that consumer surplus definitely decreases, right? Previously, it's this big triangle, but now it's only this smaller one. So consumer surplus definitely decreases. But as for producer surplus, that's going to be may decrease or increase, okay? Or now, for things like this, don't memorize, just draw it out. Do understand this, though, okay? One of them will definitely decrease, and the other one may or may not, okay? So in that case, I'm doing this recording here, and it might take quite some time. But did you do the question set yet?
But just keep going until.
Okay, then I'll just continue it. Anyways, so where are we again? The idea is to see that one will certainly decrease, and the other one may or may not. And how do we know if it certainly decreases? Well, just take a look. No, it went from a bigger triangle to a smaller triangle. But likewise, if it's producer surplus, it went from a bigger triangle to a smaller triangle. That would definitely signify decrease. So that's how we would do things like that. Okay, a bit slow, so let's get to the next one. This is about tax. All right, so we get some numbers, right? Q3 to like 7 is obviously. We get some numbers. QD equals to 400 minus 10p. QS equals to 40p. Now, that's okay. You could use this to derive your price and equilibrium quantity. But if you are to graph it out, and you should, by the way, for everything that they give you this, just graph it out. We can't just use this, right? We have to use P equals to. So let's do that. Convert it. 10p equals to 400 minus QD. P is 40 QD. Okay. And the other one, 40p equals to QS. P equals to QS. So now we have something, and we could try to graph it out. Probably going to look like this. So here we have the demand curve, right? The intercept being at 40, it's sloped down. So say it looks like this. And our quantity supply, okay, QS, we have the number like this. So we get no intercepts in that's okay. Let's go in a bit further and find our equilibriums. How do we do that? We just use the link them together. 400 page equals to 40. So 50p equals to 400, p equals to 8, q equals to 400 minus 80, right? Or 40 times 8. So that's going to be 320. So we have the p, which is 8, and we also have a q, which is 320. Not bad, not bad. But what is the question? Okay, the first one, equilibrium price, we got it 8. Number 4. Aha. Now, suppose that the government introduces a $20 tax on each unit sold. So how are you going to tackle this? Now, you could begin by just having an idea of what might happen. So if you're going to put a tax, it's going to look something like this. Okay? And you realize there's a part above it and there's a part below it. What does each of those parts mean? So let's see. The part above it is on the demand, okay? So would you expect that to be relating to the producer or the consumer? Well, it's going to be the consumer demand. Okay, so this is the amount, the price of which consumer is paying. And the part below it, but that's the price producers receive. So it's interesting. Basically, setting up this tax just means that we impose a difference or a schism between consumers' price and producers' price. Specifically, how much consumers pay and how much producers receive. And what would be in the middle? In the middle, it would be the government. This is the part that the government earns. It's called tax revenue. And we'll get to that a bit later. But the part in the middle is just the advantage that the profit that the government gets. So let's try question 4 then and say a $20 tax, right? So how are we going to do it? You don't really want to just manually draw numbers here. So actually, instead, let's go back to our formulas. Okay, we could just use this one actually. So you see, QD equals to 400 minus 10p. QS equals to 40. Now, it's good to write the P here as PD, okay? And this is going to be PS because you see supply for supply, demand for demand. And PD just means the price consumers pay, PS, price suppliers. Now, given what you know about this, is there a way for you to realize what the relationship is going to be between PD and PS? So, okay, you see the government introduces a $20 tax, meaning that this part from this to this is 20. Now, the price that producers receive is going to be lower than the price that consumers pay, right? So in that case, this number, right, PS, plus 20 is going to equal to PD. So PD equals to 20 plus PS. Now that we have this equation, we have QD and QS. Instead of writing this as 10 PD, how about we go for it as 400 minus 10, 20 plus PS, or PS plus 20. Okay, so we write it like that. And we can then combine them together because you see PS to PS, they're going to be the corresponding value. So 400 minus 10, 20 minus 10 PS equals to 40 PS. Interesting. So if we 400 minus 200, 200 minus 10 PS equals to 40 PS. So we could step ahead. 50 PS equals to 200. Okay? So PS is going to equal to 4. If PS is equal to 4, what is PD going to equal to? PD is definitely going to equal to 20 plus 4, right? So PD is 20. So now you have it. PD is 24 and PS is 4. And you see the difference between them is exactly. So now the question is, what's the new equilibrium quantity after the tax? Now there's a couple of ways you can do it. But if you take a look, right, PS equals to 4, you can go back to the equation. QS is going to be 40 times PS. It's 40 times 4, so 160. All right, that is the answer for question 4. Question 5, the incidence of the tax. How do we know the incidence of the tax? You take a look at how much the producers pay, or how much the consumers pay. And here it's asking for consumers, right? So consumer pays, let's see, right? So drawing this thing again, we have a tax here compared to our equilibrium of 8. The price that consumers pay is 24, right? And the price that producers receive is 4. So in that, producers actually pay 4 of 20, and consumers pay 16 of 20, right? 24 minus 8. So consumers pay 16 out of 20. The ratio is just 16 over 20, so 80%. Right? Consumers pay 80%. And that means they're paying 16, right? Question 6. Where did I see it? Oh, here we go. Tax revenue. So we previously talked about this, and it's going to be this rectangle here. So intuitively, what is going to be the area of a rectangle? It's going to be height times base, right? What's our height? Now, again, we can just use this rectangle where it's between 24 and 8, right? 24 and 8. And what's our base? Our base is going to be from 0 to this whatever quantity. And what quantity might this be? Well, you see, this is going to be the quantity after the tax, which is going to be the quantity of 160. We calculated it previously here. QS equals to 40 times PS. 40 times 4. If you want to double check, you could say, use the other way. QD equals to 400 minus 10 PD. Okay, and remember PD and PS are not the same. PD is specifically for the consumer. So 400 minus 1024. It also gives you 160. So our quantity is 160. So essentially our tax revenue, we calculated, it's just the difference in price times quantity. So it's gonna be, oh shoot, this is 4. 24 minus 4 times 160, which is 20 times 160. That gives you 3,200. Oh yeah, you got the answer. All right, 7. 7, the answer asks, based on real instance of tax, what can we conclude? Okay, so this is honestly sort of difficult to explain it theoretically, but the way to do it, I would say, is like this, right? So you take a look. How much percentage does the consumer pay? Consumer pay 80%, right? And producer pay 20%. Okay. So you have this, that's good, but how do we connect that to elasticity? Well, the rough idea is like this. If you pay more, it means you're more inelastic, right? Compared to the other. So essentially, what is an inelastic good? It's a good that's, you can say, a necessity, right? It's a good that would look like this as a demand curve. And when I say it's a necessity, it means that even if you increase the prices significantly, they're not going to decrease the quantity that percentage. So for example, eggs. Okay, you see, even though the avian flu and what the price of eggs have went up quite significantly, you're still going to buy a good amount of it. So eggs. And in that case, that means even if the price goes up a lot, consumers are still willing to pay for it, right? In the state of it in the last decade. So here it's sort of the same logic. You see, consumers pay so much percent, right? They pay 80%. That means that they're really valuing this good a lot, such that they'll be willing to pay more of the tax than half, or more of the tax than 50%, just so that they can buy it, even though it's an outrageous price of 24, compared to previous years. So this suggests if whoever pays more percent, or she might like to call it incidence, whoever is more inelastic, because that just says that they value the good more and they'll be willing to pay more, just to get this quantity, or just to get this good. So yeah, might there be another way to explain this? I mean, yes, I guess you could come back to this graph, okay? Come back to this graph, and you'll realize that which one is more horizontal. Oh, sorry, which one is more horizontal between the demand that looks, sort of steep, and the supply, which is sort of flat. It's going to be the supply. But that's, you don't really want to bet on that, because sometimes you just don't draw it correctly. And you might as well just rely on this, right? Yeah. Okay, so that's to question 7. Now let's do, yes.
What was the answer for 7? Is it?
Supply is more elastic.
Okay.
So yeah, a good person asked a good question. We didn't really get the answer here. The answer is supply is more elastic than demand, because we were saying, right, consumers pay more. That means that consumers, or the demand line, is more inelastic. They value the good more than supply. In other words, supply is also going to be more elastic than demand. Okay. Question 8. Now, so labor markets. Labor markets, LD equals to 140 minus 4W, LS equals to negative 10 plus W. Now, okay, for those watching the video, just a quick note here, pause and think about it, okay? Does this remind you of, the relation between Q and P? If so, what? Okay, so coming back, if you pause or not, but you might realize that P is sort of like wage, right? Price of a good, just like the wage of a worker. You're buying a person's labor or buying something, good service, right? And L, which is technically just the quantity of laborers. So this is just another way to express Q and P, except because this is the labor market, so it's slightly different. Now, the idea here is to think about what each thing means, okay? So the demand line and the supply line. Normally in a PC, a perfectly competitive market, the supply line is producers producing goods, demand line is consumers buying goods. But what about in a labor market? In a labor market, who is the supply and who is the demand? Okay, long story short, the supplier are workers because they supply the labor, right? And the people demanding work is the factory or the whatever firm. So D is demand, which is like the firm, right? But it's like the logic is very straightforward and intact, but it's very common for you guys to mess it up. So I'm gonna go in a bit later and tell you how to not mess it up, right? But let's just come back to the question. So we have this, and again, like the first thing you can do, couple really, you could choose to convert them, right? So let's go that. LD equals to, so we remove it for W equals to 140 minus LD. W equals to 35 minus LD over 4. Other one, LS equals to negative 10 plus W. We move this to the other side, LS plus W, plus 10 equals to W. So we did get that. And we can also use this part, because this is an easier equation than using this. Get our wage and quantity, both in equilibrium. So 140 minus W is equal to negative 10 plus W. Move this to that, then the other one to that, right? 5W equals 150. W equals to 30. What about L? L is going to equal to negative 10 plus 30, which is 20, right? So we do have the basics here. 30, 20, and this is 35. But how do we know this is 35? Yeah, here, right? You're using the y-intercepts. But what are they really asking for? Let's see, first one, okay, perfect competitive equilibrium wage is going to be 30. But now they're saying, right, government likes to treat workers better. They're going to give a minimum wage of 32, which is honestly very good, right? There's, I don't know, a single country in the world. 32. And in that case, how is it going to transform our graph? Okay, so you might jump to the conclusion, and it's not a wrong conclusion, to be honest. You say, okay, so we're going to have a new minimum price floor here, right? Which is minimum wage. So we have that. That's right. But having that is not enough, okay? Because what are we trying to find? We're trying to find how many workers the firm is willing to hire and how many workers supply is. Okay, so we need to find these points. Now, how are we to find those points? Well, let me use this side, okay? How are we to find those points? What's the most obvious formula? Or just something like this or this, right? So if we impose the price at 32, wage is 32, then let's say we do first one, right? This is the demand curve. Who is demanding things again? Workers, right? I'm sorry, no, the firm. A firm is demanding workers. So we could try that. LD is equal to 140 minus 432, which is equal to 120. 140 minus 128 to 12. Okay. The demand or the number of workers firm are willing to hire is 12. And what about supply? Now let's see. We're just going to use the other formula, right? LS equals to negative 10 plus W. W is 32. So LS is equal to negative 10 plus 32, 22. Right. So this point, 22, this point, 12. Not bad. You got the answer. But I want to, using this graph, say a little bit about how to not mess up the reasoning. Just maybe like 3 minutes ago, I almost messed it up. So how to not mess it up? Think about it like this, okay? If I raise minimum wage, right, I increase it. Will more workers want to work now or less? You know, like if I say minimum wage, not 30, but 32 now, some students might just ditch out of school and go work at McDonald's because 32 for an hour sounds better than like 0 at school, right? I mean, it might even be negative if you're going to private school and paying tuition. So in that case, you know, your quantity supply is going to be a higher number than your equilibrium quantity, right? Because more workers want to work when you have this higher minimum wage. But for the firm, you're going to tell them that now, you have a higher minimum wage, they're not going to be able to hire that many. Both from a technical perspective, because they don't have that much money to hire people, and from another perspective, and that is that they just don't think like 32 is a good deal for, blue collar work or something. So this is another way to just justify how okay? The one, if you raise your price, you raise your wage, the one to the right, or the labor that gains must be your supply, right? That must be about your workers gain. And the one that loses is the firm. The firm is on the demand. So that's why it goes down. Okay, clear? All right, so now number 10. So the answer, by the way, is 12 for LD and LS is 22. Number 10. Now it's asking the minimum wage policy there result in the decrease in economic surplus, or in other words, a deadweight loss. So now we're trying to find the deadweight loss this generates. So let's draw a graph here. Previously it's 30, right now we impose it's 32. We're going to have a deadweight loss, and it's going to be this triangle. But to find this deadweight loss, what do we need? What do we need? So it seems like we do have the quantity good, but we also need, we also need the equilibrium part, right? Equilibrium part is 20. So you actually do have this part, but you don't have this part yet. You have a 32 at the top. That is your minimum wage that's imposed. But what about this line? And what does this line represent? This is the line that basically says if only 12 workers are willing to work in this market, what's the price it's going to be? Right? You see, our equilibrium quantity is 20, but if it goes down to 12, that means our minimum wage must have become worse, right? So that's what you want to work in the market. Less people wants to work for anything. So in that case, we need to find this P. How are we to find it? Any idea? Okay, go.
You put it in for labor supply.
Labor supply. Yes. So very well. That's the answer. So you see, you have the top price, but you just want the bottom price. Now the bottom price is on the supply line, right? The labor supply curve, and that's good. Labor supply curve. But what is our formula again? LS equals to 10 LS plus 10 equals to W. So you're trying to find the wage, and you have an LS. LS equals to 12, right? 12 plus 10 equals to W. So what must your W be? W is, here we have it, the lower price here is 22. So to find the W loss, it's just 1/2 height times base, right? 32 minus 22 and 20 minus 12. So 10 and 8, 1/2, that's 4. So there we have the answer. And 11. 11 is asking, after the big game, what it is, maybe the Super Bowl or something. The price elasticity of demand is as such. Okay, so it comes back to what we were doing here, if you remember. So let's go back. So it gives for the LA Rams, ED is -3 and ES is 2. So it's asking how much of the burden of tax fell on whom. So the quick answer here is we again compare elasticity. Which one is more elastic? Or which one is more inelastic? Now remember, inelastic means if the E is less than 1, right? And between 0, it's inelastic. Elastic is E it's greater than 1. Inelastic is exactly 1. But the idea here is not to know if they're elastic and inelastic, but it's just to compare between them and see who's who. So don't worry about the negative sign. its absolute value, you realize that the number that is larger, right? Larger number means more elastic, right? That means it's more horizontal, something like that. The smaller number is more inelastic. Now, if we go back to the logic here, if it's more inelastic, what does that suggest? It suggests that you pay more of the burden of the tax, right? Likewise, if you're more elastic, it means you don't really care that much about this thing, but that is good, and you're gonna pay less of the tax. So we take here, we see who's more inelastic. In other words, well, more elastic, elastic is gonna be ED, right? Inelastic is gonna be ES because it's a smaller number. So that means more of it will land on the supplier or the producer. But does it mean that nobody is paying? No. And we both are, but it's just that the inelastic suppliers are going to pay more percent of the tax. They're going to pay 60%, whereas they're going to pay 40% because it's sort of the ratio. And also, I see on this question it says, what happens if it like falls equally on both? If it's equal, that just means that QD equals to QS, right? QD equals to QS, and in that case, sorry, no, EQ, so ED equals to ES. ED equals to ES. So elasticity of demand is the same as elasticity of supply. We're both going to pay part of the tax, equal amount. And also it says if it only falls on the consumer, only falls on the producer, in that case, you would have like elasticity for one of them being infinity, which really doesn't make sense in the real world. So that would probably never be an answer. Okay. Now, question 12 and 13, they're sort of bundled together. Question 12. In the market, externalities. So there are two goods, X, good X, which generates a positive externality, and good Y, negative. The words positive, negative externality is just as the phrase is. If it's positive, it's something good for society. You're going to want more of it. If it's negative, it's something bad for society. Okay, examples, electric vehicles, right? I mean, considering Elon Musk and what he's doing right now, I can't really say for sure. But okay, electric vehicles in general are what we would call a positive externality, and negative externality, there's way too much, okay? Smoking, pollution, this and that, right? So, comes back to the question. In the market for good X is a positive externality. Would you want more or less of it? More, yes. So, the socially optimal quantity is going to be greater than the current one you have. So, quantity of perfect competitive market. This is the one that society desires. You want more of it. You want like more electric vehicles because it's in general better for the environment, right? You are going to want more quantity than how much you currently have. So that's the answer. As for negative externality, well, it's like smoking, right? You don't want that much smoking or that much vaping or drugs. So the socially optimal quantity is going to be less than your current, right? You want something not as much. It's just sort of, direct logic, really. If it's positive, you want more. So optimal quantity for society is greater than your current one. If it's negative, you want less. So the optimal amount for society is less than your current. Okay, that's 12 and 13 in a nutshell. 14. Yeah, so plastic containers. They say that making these containers produce air pollutants. And what does that say? If these containers have air pollutants, what type of externalities? It's a negative externality, right? I mean, I sort of voted here pollution, but yeah, this would be definitely a negative externality. And if it's negative, how are we to expect it to go? Now, I know that most of you guys don't have the graph memorized by heart, and to me, I also don't really. But there is sort of a trick. So first of all, you need to at least have an idea, a realization that this line sloped down is your marginal benefit, and this line sloped up is your marginal cost. Right? How to get this idea? Well, first, I hope at least most of you guys would remember that back in the time of our first midterm, we were talking about how your supply curve is technically just a marginal cost curve, especially after it intersects the ABC. But for the purpose of this, there's no ABC. So we can just say this is your marginal cost. And the one sloped down, that's your marginal benefit curve. Okay? And your marginal benefit curve, why is it sloped down? The idea is sort of like diminishing marginal utility. You know, if you use more of it, you get less benefit. If you eat more chips, the first bag is good, second bag is okay, third bag starts to suck, fourth bag is disgusting, right? I mean, that applies to hamburgers, any sort of food. So that would be sloped down, because the more quantity you consume, the worse it gets. Now, we are saying this is a negative externality. So if it's a negative externality, this is, by the way, is our P equilibrium, and this is our Q equilibrium. Would you expect our quantity in a socially optimal quantity to be left of this Q or right of this Q, if this is a negative externality? But you would expect it to be left, but you would want less quantity. It's just like the relationship we derived here. Right now we have QPC or Q here, but this is a negative externality. You don't want that much of it. You don't want that much people smoking or making these crappy plastic containers that are damage to the environment. So that will be a Q sock. But how are we going to actually put this? I mean, we do get a Q sock now, but how are we to do that? Well, I mean, you think that we're going to move like somewhere like this, right? In order for our equilibrium to turn to this point. And that's exactly what you do. You move the MC line to the left. Okay, this is your MSC. This is your marginal social curve, right? This is your normal marginal cost. You move it to your left. And why is it to your left? Because your social optimal quantity is less than your current one. You don't want that much of it. So you got to put it at a higher price as well to discourage people from smoking or producing these containers. And that's how it's going to work. So as we read this question, we see the MSC, marginal social cost curve, is what? Well, it's not only above, but also to the left, right? So above and to the left of the supply, or the MC. By the way, that's also derived for positive externality. So we have the basics, right? MB sloped down, MC sloped up. But counterintuitively, it's not going to be something of movement like here now. It's going to be something about the marginal benefit, right? So here we have the QE, right? Here is the PE. And in a positive externality, would we want more or less of the good, society-wise? We want more of it. Right? More electric vehicles, more trees, more plants, this and that. So that's going to cause us to somehow move this up. Okay? And you see, it's sort of strange, but I'll get to the reason why. You move it on the marginal documents because it's your MSC, it's your MSB, your marginal social benefit curve, that is greater than your marginal benefit. And that causes, a jump in equilibrium from our old one to our new Q sock. So if we match it, yes, our new Q sock indeed is greater than our existing equilibrium quantity. But oddly enough, our price increased. You might think, right? If I want to encourage more people to plant trees or buy electric vehicles, you're going to make the price cheaper for people, right? Why does the price increase? Well, first, because this graph is accurate, so that is indeed the case. But the real reason is because in the middle of this, the government will be providing subsidies. Okay, they will be providing you with money to buy this. They are asking you to they're encouraging you to buy because the Q stock is greater than your equilibrium quantity. But to do that, they're going to give you a subsidy. And how big is the subsidy? The subsidy is going to be this size, okay? But that's probably not great. I don't think there's a question. So yeah, that's where subsidy. And here, by the way, you're going to impose a tax. Tax looks like this. Now, lastly, and this is the real tricky part, is deadweight loss. Okay, now I can't even guarantee right now, but you know, let me pull a picture. I just don't want to make it wrong. So I do have yes, so first beginning with a positive externality, our deadweight loss would actually be this point. And it doesn't make sense, but this part, right? This triangle between our QE, okay, between our equilibrium quantity and this given price. We don't really even know. It's just the price on the MSP and our optimal quantity. It doesn't make a lot of sense, right? But here it is. And what about for negative externalities? For negative externalities, I'm not sure if it makes that much sense either. It's not what you might think is here, but it's actually here. Very strange, right? Like, I mean, here at least it sort of looks like a normal DWL. It's facing right, you know, but here it's actually facing left. So what are some ways to remember this? Yeah, no. First, sort of just know the form. Just know it. See if you can get it into your brain. But if not, one of the things that I like to use is I get the direction. I get the direction. So if I know the direction that in a negative externality it's facing the left, then that allows me to derive after I get a graph like this, right? That allows me to derive, oh, it should be this. It should be this because it's facing the left. And likewise, in a positive externality, I'm going to derive so here. I know it's facing the right. So, oh, it probably should be this. So yeah, that's how I would do it. I don't know if it helps. Okay. 6 more questions to go. So what's next? 16. All right. No, hold on. Oh, 15 we didn't even answer. 15 is a completely conceptual question. It's sort of fun, actually. I like it. Public goods are non-rival and non-exclusive. Because of their intrinsic nature, public goods generate a what? And the long story short, the answer is free rider problem. Okay. Why? Well, because public goods means it's what? Non-rival. Well, it's non-excludable, non-rival, right? Non-excludable means that you don't have like a ticket or a price that prevents you from using it. You could just use it yourself. It's like a radio, you know, you could just plug it in and you plug it into the station and you'll get it. And non-rival means that one person using it would not stop another person from using it. Okay. Well, what is the free rider problem? The free rider problem is when nobody pays for this. Okay, so people just use it for free. Like 70% of people on LA Metro and Bus, they use it for free. And the issue of that is, well, first, for LA Metro and Bus, it's not a public good. It's public transport, but there is a cost to it, you know, $175. So that's no. But here, why it's a free rider problem as well is because technically, public goods say that they're paid for you within your taxes. For example, the most common public good would be national defense, right? Or like parks, something like that. And those are things that the government uses for taxes to pay for. But if a person doesn't pay their taxes, right? But they still have access to this. They're still protected by the government or, you know, the military. But, you know, they technically free road, and that's the problem here. Another common question might ask, okay, two actually related to this. First, public schools. Are public schools, are they public goods? Any ideas? Well, let's analyze it both ways. Excludability and rival, right? So, public schools, are they excludable? No? Yes? Any idea? Brad? No? Okay, well,
No, they aren't.
they actually are. Okay, they actually are. It depends on school district, right? If you're gonna go to schools in Chino Hills, it can only be in that district around the area. You can't go for it in Inglewood or somewhere else. So it actually is so it actually is excludable, right? So you are automatically no, it's not a public good. But what about rivals? Is it a rival? Is it non-rival?
Rival?
Yeah, it actually is rival as well. Because one person taking your spot actually prevents another person from using it. Right? And especially this would be, in a school of limited space. If they let one person in, that means another student would have to go to another school. So public schools would actually be an example of not a public good at all. They don't satisfy any of this. Okay. There's also a question under extra practice which says a half empty theater, and they're asking if it's a public. It's not a public good for sure. You need to pay, and so it's not even excludable. But they're asking if it's rival, and personally, I don't like this question. I don't really get the gist, right? But sorry, this is excludable. Non-excludable means that you can't prevent something. This is the reason why it's actually non-rival, right? For that particular question is because there's still like half of the room empty in the theater. So technically you using it wouldn't prevent another person from using it. It's only when the last space is filled, then technically it becomes a rival. I don't like the idea there. Don't really understand it. I would say it's both excludable and. But there's a question in extra practice, and the answer is it's not a public good just because it's excludable, but not because it's right. Okay. So now 16. All right. External benefit. These questions sort of straightforward, but she's going to make it harder for you guys on the quiz for sure. Tesla. So MB equals to 100 minus Q. MC equals to Q. And all right, we can technically draw it out already. It says it's a market for positive externalities. So you'll know this is MC, this is MB, and we're going to have an MSB that is going. Now the question is, what exactly is the MSB? So what's the relationship between MB and MSB? So obviously you see the MSB is to the right of MB. That probably means that MSB needs to be MB plus something. But what exactly is this gap that you need to plug in the plus? Okay, so the gap is called your marginal external benefit, right, MEB. And that's also provided in this question. So you see, MB equals to 100 minus Q, MC equals to Q. By normal equilibrium, that's, you just plug it in. MB equals MC. MB equals to MC. Shit, I'm out of there. That's the case. So yeah, MB equals and 100 minus Q equals to Q, 2Q equals to 100, Q is equal to 50. All right, so that is our normal 50. And what's our P? Well, P with this part is just going to be to be provided. That part is also going to be 50. Right? But now the question is, what about the Q sum? So what's your socially optimal part? So take a look. MSB equals to MB plus MEB. Do we have MB itself?
MB equals to MC, right? They're both equal to 50. Because again, Q equals to MC, so they're both equal to 50. But you take a look, what exactly is your, come back. MEB, okay, so now we have MSB equals to MB plus 2, right? So if we go back to the original formula, that's 100 minus Q plus 2. So 102 minus Q, okay? And in that case, so it's going to be our quantity here. We would need to merge MSB with MC. So instead of doing MB equals MC, finding this point uses MSB equals MC. Okay? So in that case, 102 minus Q equals to Q, 2Q equals to 102, 51 equals, so there we have it.
But I want to remind you guys in something, and I think it's very, very important.
You can't just, after you get the Q, you're like, okay, MB equals to Q, MC equals to Q, they're both equal to 50. And you're like, oh, I also know MSB equals to MB plus MEB. MB is 50, so MEB is 2, right? So MSB is 52. It's not right. Okay, you have to resort to this formula. You have to go back to it. You can't just use this, right? That's wrong. If it's on a question like this, she kindly didn't provide you with the answer towards the 52. She only gave like odd numbers, right? So that's good. But if you might say it's 52, or it's not. Okay, so yeah. Actually, hold on. Did I explain this one? Oh, okay, I see. So no, I think this actually is correct. I'm sorry, this. You see, this one we're trying to find Q. We're trying to find Q. This one we're trying to find MSB. Now, if we do use MSB equals to MP plus MEB, that's going to be 102, right? If you go back to this formula, MSB equals to 102 minus Q, and our old Q is, well, at this point, we're going to have a Q of 51. But this, if we use the old Q, right, the old Q of 50, and we plug that in, that's going to be 102 minus 50 equals to 52. And this number, which is this number, by the way, actually has a point. The purpose of this point is it's the number here. That number is 52. I sort of messed up the order of explaining this because we actually use this to find the substitute really, but you see this, we get this point price being 52, and in that case, it also allows us to find like the deadly loss. So the reason why we have 52 is here. That is your price according to the quantity of 50 on your MSB load. Okay, and to achieve efficiency, now first, this is a perfectly, this is a positive externality. So that means you're going to impose taxes, subsidies, yes, subsidies. Okay. And how much of a subsidy are we going to do? Well, the idea here is you could so MB equals to this, that equals to that. And you want the optimal quantity to be 51, right? So if you want the optimal quantity to be 51, then how are you going to achieve that? Well, MB equals to, MB is $100 minus Q, right, equals to 49. MC is equal to Q, which is equal to 51. So you take a look at the difference, and that's sorry, I didn't see it. So you take a look at the difference between MB and MC. MC being this point and MB being this point. And that you get your subset. But not the best explanation. So because this question is honestly it's not your typical subsidy question. Oftentimes she would give you an MEB which equals to like 3 plus 3Q or something, and you use the optimal quantity. You use the optimal quantity, which is like 4. So that's 3 plus 3, 4. This is just a hypothetical question, equal to 15. You get your MEB, and basically that also gives you your per unit subsidy. Here it doesn't really allow you to do it, but when you do, like the same logic is you take like MEB equals to 2, right? So that's actual subsidy. That's another way to find. Okay. And all right, last part, finally. External cost limit. Okay, long story short, MB, MSC, and MC. If we are going to find the dead weight loss, well, where is the dead weight loss? The dead weight loss, remember, in a negative externality, it's facing left. So it's actually this part. So you just plug in the numbers that are corresponding there. You take a look, oh, the top, I think, is 95, right? 95. The bottom, which is the equilibrium in your perfect competitive market, is 45. And your quantity here is 15. Your quantity here is 11. So you just dead weight loss, right? 1/2, 50, the difference of this times the difference of that, which is 4. That's going to give you a dead weight loss of 100. Yeah, and the next part is asking for your tax. So just like what we sort of did here and here, you're using the socially optimal quantity to determine what exactly amount of tax we're going to do. So in this question, you see looks like this, right? And this is 95, 75, 75, 45, and 30. And this is your socially optimal quantity. This, however, is your equilibrium quantity. You're going to use whatever you have in your socially optimal quantity. And specifically, you're going to use the points here. And what are these points? Well, this is the MSC line. So this is when your quantity, socially optimal quantity, hits your marginal social cost. Okay, and this is your marginal cost line. So this point is when your social optimum quantity hits your marginal cost. So between this and this is actually your tax, and your tax is this. Equals to 75 minus 30 is equal to 45. So there is the answer. Now, takeaways from this. So regardless if we're doing a subsidy in a positive externality or a tax in a negative externality, you are going to use what? Yeah, you're going to use the social optimal quantity. Okay, don't think about the equilibrium quantity, just use socially optimal, and that's the way to go. Okay, apparently this meeting is longer than expected. It does take me much shorter time to do it myself, but when explaining to you guys, I feel like I need to be a bit more specific. I expected 40 minutes, but that's that. And that's really it. Okay, I'm not going to do the extra practice because we have no time, but they're really worth it, right? Definitely do it, or definitely do it also before the exam. And the solutions is pretty specific as well. So just good luck on that. All right, and see you later.